So, dear participants, the session I will be talking about developing employability skills through project work. Here, sir has told you that there are a number of skills. We call these skills as soft skills and hard skills, or we can call them as technical skills. So, in this part of my session, I will be mostly talking about the technical skills which are required. So a little bit, sir might have already covered introduction to projects, but when we talk about projects, basically for faculty there are two types of projects. We call these projects as sponsored projects and consultancy projects. So sponsored project, these can be for the students also. So a brief about these projects are that after that we will do the skills which are required, the technical skills which you should give to your students through these projects work, so that they can come to know about these technical skills. So dear participants, a sponsored research project is that project which is sponsored by some agency, means some government agency, some national agency, international agency, some autonomous agency. So basically, this is a time and cost bound project sponsored by government, private, public, or national international agency. The project cost, including the cost towards contractual manpower, deputed manpower, equipment, consumable, and support services of the university are borne by the sponsor. That means the entire cost for undertaking that project is given by the agency, government agency. Any agency it can be. Sometimes some private agency can also sponsor you, but mostly these are government agencies. The now in this, who is the sponsor? The organization that sponsored the project to the university will be the sponsor. Like sir told you that I have done certain projects, so I have also done some sponsored research sponsored by DST, Department of Science and Technology, sponsored by AICTE. So they give you grant for doing that project. But before that, you will have to write the entire project report and submit your project to that particular agency. So the organization that sponsored the project to the university and gives necessary financial support for the successful completion of the project in time is known as the sponsor. Now, who will do that project? The principal investigator. If I am writing a project, then I am the principal investigator. So I will write a good project, and I will submit it to a particular agency, AICT, DST, any agency we want to submit. Then they will see your project work which you have submitted. In that project, you will have to write, this is the work I will be doing in 3 years. This is the work I will be doing in 2 years. For this I required this equipment. You will write down the cost which is required. You can also hire a person under your project work. So a faculty member or university with the necessary expertise and competence to conduct a sponsored research project, that the person is a principal investigator. Normally the faculty member who submits the project proposal and discusses, negotiates it with the sponsor, is instrumental in getting the project, is the principal investigator. But mostly we keep one co-investigator also with us, which we call as co-investigator or co-PI. So any faculty member who is from the same field, you can co-opt him as the your co-PI to work jointly with him. If the PI leaves the university, then the co-PI will assume the power of the PI. So if you wish, I can also show you various sites where you can write these sponsored projects and you can submit. If any one of you want it, I can show you one slide where all these projects are available. So responsibilities of PI. What are the responsibilities of this principal investigator? He is responsible for the formulation of the project proposal according to the format prescribed by the funding agency. The project proposal may include planning of various project activities, estimation of funds required for the project, taking into account the different budget heads. So you will have to write, what is my budget for this planning? You have to plan the various activities, how I will do that particular project. These are the responsibilities of the principal investigator. So if you are hiring under that project, you can also hire a staff member. So what will be the salary of the staff? What are the cost of the equipment? What will be the cost of the consumable? If you are traveling cost, these are the different heads under which you can write, okay, I want to apply for this project, and this is the cost which I want. Then preparation of statement of expenditure. Another responsibility of the principal investigator is, after the project is complete, you will prepare the entire detailed statement, how much money has been spent. You will prepare the utilization certificate at the end of the financial year, and you will submit it to that particular agency. So anybody so after this we will discuss if any one of you have done this, any of these research projects. So second type, so sometimes there are certain agencies which gives you projects, which give you money for doing the students projects also. So like from DST we have this under DST NSTED, we have, they provide you grant for doing some project works. You just have to apply a project, 10 good projects. So they give you money for doing that project also. So participants, the second type of projects which we have are consultancy projects. So what is a consultancy project? It means consultancy assignment or job given by an outside agency to a faculty for work within mutually agreed scope. Like SK Gupta sir might can tell you, they are doing consultancy project of these curriculum development. So that is in the consultancy mode. When some any other agency, they hire you, okay, this is my particular work, kindly do it for me. So they then that is known as a consult. It is not sponsored, but it is a consultancy project. It is similar to sponsored, as it is also time bound, specific problem solving project sponsored by funding agencies with payment of consultancy fees, honorarium to the investigators in addition to all other expenses. So in this case also, you will appoint a principal consultant. Now there are two ways in which you can do the consultancy project. Either you yourself have so many contacts that somebody contacts you, okay, please do this project for me, maybe in civil department or whichever department you are. Or sometimes they approach the institute also. They may approach your institute and they may say, okay, this is the type of project work we want to get it done from the institute. There the head of the institute will identify who is capable of doing that particular consultancy project. So a faculty member is approached for the work. He will be identified as the principal consultant. The project proposal prepared by the principal consultant will be forwarded to the client. So what do we have to do in the consultancy project? So in the consultancy project, we have a principal consultant who will be responsible for formulating the project proposal, which may include planning of the work, estimating costs according to guidelines, identifying other consultants if necessary, execution of work, handling all communication with clients after the project has been accepted. So basically, you will make a total project plan of 3 years or 2 years, whatever is the time period. Okay, this is the work which we will do. Then you will also estimate the cost. Okay, this is the cost. You can also put the salary of any person if you are hiring. Then you can identify other consultants also. Okay, cannot do it alone. I require 3 4 more people who will help me in this work. Then execution of the work. You have to execute the work. Then handling all communications with clients after the project has been accepted. So this is the type of project that which we call as the consultancy projects. So we have two different types of projects: research projects or consultancy projects. Third type which we do get it done from our students are known as the project work which the students do in their colleges. So in this consultancy project also involves writing of intermediate and final reports according to the project proposal, making recommendations to regarding the expenditures from the project funds and disbursement of funds to participants in the consultancy project. The project file will be closed with the submission of final project report and disbursement of fees to the consultants and others. So dear participants, these are the different types of projects which we do. If you wish, if you can see, just simply if I just show you one website, that is AICTE website. On AICTE website itself, there are number of initiatives or schemes or projects which you can apply. If you go in the schemes, sorry, so there are different schemes for which you can apply. See, these are faculty development schemes. Then for the institutional development schemes, research and innovation development schemes and journal schemes. You just click here, like for example, on faculty development schemes. These are the project proposals which you can send. So AICT, NITTT, AICT Quality Improvement Program. So if you see here, this is a very simple research promotion scheme in which you can apply for a project, and they give you about 25 lakhs for the project work. So I will not go in detail. I've just shown you this website. So three main agencies which provides you a lot of projects are, so the AICT and DST. So here you can see there are certain student development schemes also, fellowship schemes for the students, then some schemes for the institutions also. If you want to have an idea lab, if you want to have certain other grants, modernization of modrops. So from here you can see from the AICT website the various project proposals which you can apply and for which you can get the grant. Any of you have done any project work? any uh, any participants who has done any project work, consultancy project or any research project? The second type of projects which we give is to the student. Yes.
Excuse me, madam.
Yes.
Uh,
Yes,
myself,
Rajesh.
myself R.D. Umri Karna from Government Polytechnic Ahmednagar. We are having diploma institute here, and our students are having industrial training in fourth semester, and in fifth and sixth semester they are having capstone project. So can
Good,
we
good.
get sponsorship for diploma project? What we can do for that?
That is wonderful, sir. That is wonderful. So good that some students are doing project work. So Rajesh sir, wonderful. Now the next part, this is the one introduction I have given to you about the different projects which
Good
you
morning,
have.
madam.
Good morning, Vishali ma'am.
Acha, I am Vaishali Hivre from Premlila Vithaldas Polytechnic. It's
Yes.
in Mumbai. Actually, we have diploma in food technology and degree in food processing technology, two
Okay.
courses. So my diploma student last semester they have done one industry sponsor project, and degree students are doing four industry sponsor project right now. Okay,
Wonderful,
so
wonderful. So here,
so.
good, Vaishali ma'am. So
I,
this is,
my, I just
yes,
wanted to know if we are taking it as a consultancy.
yes,
So what are the charges or percentage of the fund allocation to the
yes.
institute or to the faculty?
Okay, so Vishali ma'am, this is a wonderful question. For this, you will have to make some norms for your institute. For example, in our institute, we have made some consultancy norms. Okay, if there
Mhm.
is a consultancy, suppose 1 lakh consultancy is there, then you will have to divide and you have to make a percentage that okay, 20% will go to the coordinator. Like Vishali ma'am, you brought one project and you
Right.
are doing that project, so it is
Mhm.
not that the entire 1 lakh will go to you. There have to be certain heads under which you can divide it. But you will have to make a proper proposal from
Mhm.
from your institute. Okay, if we get a project, for example, mostly we give 20% to the coordinator. That means 20,000 will be given to the coordinator who is doing, 20,000 will go to the institute. Then other people who are involved, if account people is involved, if your head is
Mhm.
involved, so a framework has to be made. If you don't have a framework, then if you get some particular project, you can get it approved from the head of the institute. Okay, this is the project proposal I am getting. So this percentage will be taken by me, like this you have to do.
Is
Because
there any AICT norms or DTA
no, no,
norms?
no. There are no fixed norms. Every institute, for consultancy, you will have to make your own norms. For
Okay.
research project from AICT, and they have their own norms. There, they
Mm.
give you money for the equipment. They will give money for doing the research work. They will give money for traveling. All these costs, there are different heads. Like I also did one AICT project. They gave me 25 lakh. So first of
Mhm.
all, before applying, you will have to write, okay, out of 25 lakh, 10 lakh I will be using for buying this equipment, 5 lakh I will be using for this. So detail has to be given and you will have to use it within that. But consultancy is in your hands only, because consultancy is what you are getting individually from some sponsored company. See, different types of consultancy you can do, Vishali ma'am. Like if you have some equipment in your
Mhm.
food processing, so you let us say we have this some good microscope. Somebody else
Mhm.
from industry want to take some samples. So you give a
Hmm.
cost. Okay, okay. From each sample we will take 2,000. Out of this 2,000, 1,000 or 500 will go to the person, the technical person who will be doing that testing. Some will go to the institute. Some will go to the fund. That is how you can do. If you have some good machinery, which industry? This is what type of consultancy institutes are doing. Like we have this SEM micrograph. We have 3D printer. So we have given certain rates. Okay, if you want to do 3D printing, this is the cost of that particular sample you want to do. But you will have to keep some share for the person who is doing. If you are the coordinator, if you are handling that machine, you also will only do if you are getting some benefit out of that.
Okay, ma'am. So there are no fixed norms, rules and regulation
You
by the
you
government or.
you will have to make it for your own institute. For consultancy, we don't have research projects they have fixed.
But if research projects are sponsored by industry,
Then the industry will tell you, okay, that we like here we are doing, like sir is SK Gupta sir is doing preparing curriculum for Haryana state, Punjab state. So individually
okay.
both of them will sit together, they will negotiate among themselves, okay, this is we want to do. So that is on mutual basis. So industry can say,
Okay.
okay, do this project. Like you are from food industry, suppose they give you
Mm.
some sample or they ask you to make some product. So the
Mm.
both of you can negotiate, okay, this will be my cost. So you will have to make a project report there also. Okay, for making this, I will require, this is the amount I require for raw material. This is the
Mm.
amount I require for preparing it, and this will be my own charges. So mutually, both of you can sit together, and the industry and yourself, you can negotiate and you can come at a final cost.
Okay. Thank you, ma'am. Thanks a lot.
Okay, wonderful. So this is how you can do some project work. You can do some consultancy work. I will give you one link. I have not added in this slide where all the link for all the sponsoring agencies, DST, AICT, DSIR, all the agencies who are providing you these funds for doing project work. I will give you that link. But in my further so all of you are aware of this. Now in my further slides I wish to explain, okay, what are the we have two types of skills. So soft skills, all of you are aware of that, that a student should have good communication, a student should be able to work in teamwork, so that is common. But the second type of skills which is very important for any technical institute is the technical skills. All of you must be aware that with these industrial revolutions, with the advancement in these skills, there is a wide requirement that your students should be aware of these skills which are required for the industry. So dear participants, we will be only talking about the technical skills, the hard skills which are required for any student who is going to the industry. So what you can do is, okay, you make certain projects which are having some latest technology. Like ma'am is talking about food there. So you will be astonished that in food we are also using additive manufacturing. We are also using this 3D printing for food industry also. So what is required is that already we are teaching them some curriculum. Some curriculum is being taught, some syllabus is there, but they are not able to cope with the latest trends which are occurring in our industry, which we call as industrial trends which are taking place. So, dear participants, you must have heard about these latest trends which are there in the industry, that is Industry 4.0. So, here today we are going to look into the different industrial technologies which are there. So if you are aware a little bit of history of revolutions, industrial revolutions. So if you are aware, we had this first industrial revolution, second, third, and now today we are in the fourth industrial revolution and on the brink of the fifth industrial revolution. So these industrial revolutions, first industrial revolution started with the steam engines. Before first industrial revolution, just imagine there were no machines, no work was done by machines, everything was done manually. So when this person James Watt introduced this steam powered engines, where water was the source, water was converted into steam, steam was used for doing work. So there they started using this steam energy, steam engines for doing various types of works, like flour mills, preparing of flour, iron works, distilleries. Then the major use was for making in cotton mills. Otherwise, before that, they were using charkha with hand. Now they could use the cotton mills. So lot of work started being doing with steam, and then steam powered locomotives were also used. Otherwise, the transportation was by foot or by animals. So steam powered locomotives being started used. So after this, we came to the Industrial Revolution 2, which was from 1863 to 1947. There was a person known as Henry Ford. He took the idea of mass production from a slaughterhouse. Before this, the work was done, but it was very slow. So this person, Henry Ford, he actually once happened to visit one slaughterhouse where they were preparing the meat. There he saw that instead of doing work at one place, this pig was converted into meat. This pig was moving on a conveyor belt. So participants, from here the mass production idea came. So this pig was tied here and it was moving on this, and each person was standing on its own place and cutting part of this, and by the end of this, the meat was cut, prepared. And he observed that this work was very fast. Instead of one person doing all the work, if it is moving on a conveyor belt, then the work is done faster. So this person, Henry Ford, who was the owner of Ford at that time, he introduced this concept of conveyor belt in his industry, and he started using and mass production of things started taking place. So if you see here, the same concept of conveyor belt, he applied it on his on in his company. And if you see here one part which we call as the flywheel, this flywheel is traveling from here. Each person is standing on its own place and doing one job. And by the end, this flywheel, by the end of this conveyor belt, this flywheel was complete. So this is how Industrial Revolution 2 took place. During this Industrial Revolution, lot of large scale iron and steel production took place, machinery, telegraph, use of petroleum and electrification. All these concepts came during Industrial Revolution 2.0. It is now considered as the most large industrial revolution. Maximum revolutions took place during this period. Then we moved to Industrial Revolution 3, where we are part of this, where computers, memory, programmable controls, automation, all these started coming in Industrial Revolution 3. Telecommunications, electronics, then computers, PLC, programmable logic controllers, and robots, all these took place. Now, some known examples of this are robots. In the second half of the 20th century, we saw another very important untapped source of energy, that is nuclear energy. So let us move to the present skills which we require. The skills which we require are known as the skills required for Industry 4.0. Now, participants, we are today in Industrial Revolution 4.0. That means we need to give some projects to our students which are related to Industry 4.0. What is Industry 4.0? It means communication technologies, information and communication technologies to industry. Production systems that already have a computer technology are expanded by a network connection and have a digital twin. And the production is automation. So we talk about digital twin also. So this is the major part of my presentation. Okay, in what type of skills we need to give. So these are the technologies which are driving industrial revolution, and you need to give your students some project works in any of these technologies, one or two of these technologies. What are these technologies? We are familiar with many of these technologies. One is autonomous robots, artificial intelligence, horizontal and vertical integration, industrial internet of things, cybersecurity, additive manufacturing, augmented reality, and big data analytics. So these are certain technologies which are driving Industry 4.0. And as faculty, it is our duty that we give our students some project work related to these technologies, right? Autonomous robots, artificial intelligence, some IoT. So all of you must have heard about these technologies depending upon your area. If you are from computer, you must already be knowing about cybersecurity, big data analytics. From mechanical point, you must be aware of robots. and then this additive manufacturing. So we need to teach our students skills in these latest technologies, that is industry 4.0, so that by the time they come out of their diploma or they come out of their degrees, they are able to work in these technologies, because these are the technology we already, you are aware how artificial intelligence is changing, how everything we are doing around. So we need to provide them skills in these technologies. So I will briefly try to cover these technologies. Then I will show you a small video regarding the skills required for the future, that is industry 4.0. So after this introduction, we will have a small discussion and we will discuss how many of you are already teaching these types of technologies to your students, or skills related to these technologies. So our purpose here as faculty is to tell them about these technologies, give them some project work in the related field, so that by the time they come out of their degree or diploma, they already know these skills, right? So, what is Internet of Things? Internet of Things describes the network of physical objects that are embedded within the sensor. Basically, these are the sensors. Like we have our own senses, eyes to see, ears to listen. Similarly, we have small sensors which can sense certain things. Then these sensors are connected to the software and they exchange data with each other. For example, a simple thing is that if I am using IoT in my agricultural farm, so what I can do is I can put a sensor in the farm, in my soil, and instead of, if there is no sensor, what will a farmer do? He will go to his farmland. He will see कि, okay, the amount of moisture is less in the land, I will have to water the plants. So he will switch on the water pump and water the plants. Similarly, he will check the quality of the soil. Okay, there is a requirement of fertilizers, or there is requirement of pesticides, so he will spray the pesticides. But if there is an IoT sensor embedded in the soil, that IoT sensor will sense, okay, now the moisture is less. It will it will provide that data through a software to another. It will provide data to another sensor. That sensor is connected to a water pump. That water pump will switch on the water, and automatically the water will be given to the plants. This is how we are talking about industry 4.0. This is how we are talking about connection of various parts. Similarly, these things will happen in industry. One sensor will communicate with another sensor, and they will make decisions based upon that. Similarly, another sensor is there which will see the quality of the soil, check the quality of the soil, and it will see, okay, there is a requirement of fertilizers. It is connected to maybe a drone. That drone will automatically spray fertilizers to the soil. So this is what you can do. So here's participants, you can give small projects in IoT. If there are from electronics or computer students, give them small sensors and ask them to use it for various applications. This is how we can provide them certain skills. Another very important thing which is going is artificial intelligence. That means the computers can think like humans. How do they do that? What is the basic fundamental behind that? In artificial intelligence, actually they recognize the complex patterns, they process the information, and then they draw conclusions and make recommendations. So recognizing the complex pattern, whatever you are doing daily, they recognize that pattern. Based upon that, some information is drawn, and then they are drawing conclusions and making some recommendations. This is what we are doing with artificial intelligence. Some examples of artificial intelligence are Siri and Alexa. You all are aware that if when you switch on Siri, if you ask it, okay, or Alexa, please play my favorite songs. How does it know these are your favorite songs? Maybe you are already listening to old Hindi songs. So based upon that, it will make a decision okay, they are this person is fond of old songs. So it is recognizing your pattern. Can you see here? Recognizing what we have written, recognizing your pattern, then drawing conclusion from that and making recommendations. If you are fond of watching some program on Netflix or some other TV show, then they will recommend you similar. Have you seen this? Participants, it will start recommending you similar type of programs. But how it is making, that means it is thinking and making some decision. That means it has the ability to make decisions after thinking or make based upon some process. Similarly, these drone robots, manufacturing robots, they change their path if some obstacle is there. That means it is making decision. Then your healthcare treatment recommendations. If you are wearing a smartwatch, after some time it will recommend you. Okay, stand up. You are sitting for a long time. Some robot advisors are there. Have you imagined why some spam filters? Some emails go in the spam automatically. Certain mails go in the spam. I have not asked it to it, but based upon some pattern, it is giving some mails in the some mails are going in the spam. So all this is based upon artificial intelligence, AI. Then there is another very important is the virtual reality. It refers to a computer generated simulation in which a person can interact with an artificial three-dimensional environment using goggles. You all are aware of that. You wear a goggle and you go into a new environment in a virtual environment which is not actually there, in a simulated environment. A very, very simple example is when we watch a 3D movie. So there you experience as if you are a part of the movie. Some car is speeding very fast on you, and some leaf is flowing, and this is a example of virtual reality. That means you go in some other reality instead of at your place. So there is another reality augment. So basically they are using these augmented reality, virtual reality for doing certain efforts, various application in industry. I will show you a video where they will show you this. So augmented reality overlays. Augmented reality means, augmented actually means to add. So your environment, some in, you are in some environment, and there you add some part that is known as augmented reality. For example, Google Lens, Snapchat, all these are examples of augmented reality. Here we can see that in your room you are checking through augmented reality whether that sofa set will look okay in that environment or not. So this is your augmented reality, adding something into that room. So additive manufacturing, commonly known as 3D printing, additive manufacturing is the process of building an object by depositing material in multi layers. All of you are aware of this 3D printing. That means adding layer by layer. How does this 3D additive manufacturing work? Because additive manufacturing can be done on demand. Production time for those customized product is why we are talking so much about additive manufacturing. The major advantage is in your biomedical applications. When you have to make some body part, customized body part, there we are using this additive manufacturing. So a little brief about what is this additive manufacturing. If you see here, this is the part cup which we have to make. This is the final cup which is required. So what we do in 3D manufacturing, we first make a CAD document. We first make a drawing of that cup, then we convert it into an STL convert format. Actually, this STL convert format is a sort of network where it will take the coordinates, how to build that material. So the machine will take coordinates, it will prepare the entire program, how, where the material will go. So in this, if it is, if the material can be in powder form, of in case of plastic, it can be in the form of filament. So simply you have to, what is your input? You just have to provide the powder, the material from which you have to make that product, and you have to provide a file, the final product file, that is CAD file. In the second step, we convert it into STL convert. Then we transfer it to the machine. The machine will calculate the coordinates like you see in the figure 4. Then it will automatically work inside this. And the final product, if you see this point number 7, let me enlarge this. In figure number 7, this is the final cup which we will obtain. Then you polish it, paint it, remove the extra material and remove it from the plate. Your final product will be here. So this is in brief the additive manufacturing. So these additive manufacturing is now being used for medical field also. A lot and lot of applications they are finding in medical field. If you see here, they are using for making even tissues. Your skin is even made by 3D manufacturing outside the body. So drug delivery, they are using equipment of lab and test. Then some tools which are used by 3D printing or additive manufacturing. Then some prostheses. If you have some accident, we want to put one part. You must have heard that a metal rod is been put, or we are doing some knee surgeries. So depending upon the type of knee shape and size of the knee, we can 3D print that knee part outside in the lab. Similarly, some accident is there, we have to put a rod or some screws. So for all these, the various applications of 3D printing are used in medical. Then they are also using some models to make model of kidney, liver. So 3D printing, using different colors, they are making these models. Then there are certain instruments also, instruments for surgery and all, they are making by 3D printing. These are certain plants which are already been used, specific implants made by 3D printing. They are printed on the 3D printer. We also have, these are the two printers we have in our lab. Bio printer, 3D printer we have. Then a very, very new application of this is in tissue engineering. It is finding a lot of applications. What do they do in tissue engineering? By, if suppose some part of your body is not working properly, so by doing biopsy, they will extract the cells. Now these cells are isolated, and they grow these cells outside. Cell culture is obtained outside in the lab, outside the lab. Then this cell proliferation takes place by in the lab, and we make this 3D scaffold by using 3D printing. This is to provide the strength, tissue strength. So the cells are grown here, and the final corrected tissue is then implanted inside the body. So you are removing a cell from the body, growing it outside, then you are substituting it with the fresh, healthy tissue inside the body. So you have seen this, there is a culture of taking stem cells when a child is born. Anyone of you have heard of this? That when a child is born, they keep some stem cells from that body. The reason for that is that the stem cells are used for if some, if that child has some disease in the future, then they can grow that stem cells and replace it by the correct cells. They will grow it outside in the lab, and they can replace and some disease which is there, that can be removed. So participants, these are the two printers which we have. I showed you one bio ink printer. This is a very special printer, 3D printer, which we have. Then we have ABS polymer based printer also. On this 3D printer, this is the plate, and these are the samples which one of my students have drawn. These are of steel samples. So basically on this plate, first we had made the drawings of these samples, and we had put the powder inside this stainless steel. So these samples were made on this plate. So you just remove the samples from the plate, and we get the 3D printed samples. So, dear participants, any one of you have heard about this 4D printing? Now, after 3D printing, we also have a 4D printing concept. 4D means 3D printing, changes in 3D printing with respect to times. Means you have made one product, like this is a 3D product which I have made. And this 3D product, I have made this 3D product, and this 3D product can be converted into 4D. How? If it is able to change any of its property with respect to time, then we call it as 4D printing. For example, if the pressure at certain place is different, then it changes its shape depending upon the pressure. Like you have seen, small sponge type material we have. If you put water in that, it expands. So that is an example of 4D printing. So these 4D printing can, the characteristics of these objects include any change in color, size, form, or any alteration due to changing environmental factors or triggers. So a very good application is, these changing environment can be pH level, water, pressure, temperature. Now they have started making 4D medicines also. Have you heard about 4D medicines, anybody? So I was reading this paper on 3D printing and 4D printing. What they have done, they have made certain capsules which will go inside your body, and inside your body, if the pH level at certain particular place is 7, then it will expand and it will give some controlled amount of medicine. And the same medicine, if it goes into another part of the body and there the pH value is suppose 4, then this will release different amount of medicine from the capsule or from the tablet. This is how the 4D printing, they are using 4D printing in medicine. That means working under different conditions, it is giving you different amount of medicine. This is how they are latest using this 3D concept to 4D printing. So, dear participants, all of you are aware of then robots. This is again in robots, a very upcoming field is drones technology. Lot of engineering colleges and polytechnics already are teaching drone technology to their students. So, in robotics, autonomous robots, we can teach them how to assemble a drone, how to make a drone. So, robotics is again a very important field. So before I go to industrial metaverse, dear participants, I am not able to escape from here. So this video will show you what are the skills which are required for the industry of future. Is it visible?
Yes, ma'am. Perfectly audible and visible.
In this video, we're going to show you how big, bold technology leaps are enabling sustained productivity gains in UK engineering, manufacturing and distribution, and how you can join in. Right now, in Europe, raw materials, parts and components are making their way independently through the production process, with machines, products and sensors spontaneously communicating with one another, making decisions without direct human intervention. The Advanced Manufacturing Research Centre is backing that vision of the future by building a brand new £40 million factory in Sheffield.
So we're bringing together industry experts, academics, backed by government to really focus on innovative products for reconfigurable manufacturing. We're here to develop the understanding, adoption and deployment of them throughout UK industry. And we're looking at augmented reality, taking information from the CAD system and displaying it on parts like a wing. And 3D printing is changing the world in terms of the ability to prototype much quicker than we've been able to in the past.
That sounds great, but how can businesses get involved?
We work with businesses from large OEMs to tier ones and SMEs, so really we take inquiries from absolutely anybody.
One of the new technologies that's captured everyone's attention is virtualization.
The idea is a simple one. You take the miles of conveyor belts, motor drives, scanners, elevators and machine tool components and raw materials, and then you put all that information into a software package and create a virtual factory, an exact replica in fact of the real physical factory, because the virtual factory enables you to take a real-time big picture view, identify areas where you can improve efficiency, cut out waste and prevent problems occurring in the real factory. But the biggest thing virtualization delivers is the ability to add more innovation, more flexibility and most importantly more productivity. Today every sensor button and monitoring device has the potential to become a participant in the Internet of Things, each with their own IP address. These so-called cyber physical systems will eventually enable machines and workpieces to communicate with one another and make decisions within the process. Employees can use virtualization to check the product meets the required quality standard and is ready to be shipped to the customer. Today, your IT infrastructure is becoming more important than your raw materials, machine tools and physical assets. Cloud technology is enabling infrastructures like this to become part of a global ecosystem of suppliers, partners and customers. A connected supply chain speeding up decision making, collaboration and innovation. The companies who thrive in this new world may not be the biggest right now, but they certainly will be the most flexible in the future, with the ability to customize the product to meet the ever-changing demands of their customers. Customization is great because it requires zero inventory, everything is made to order, and there is no waste. The step beyond customizing is individualizing. An entire product is made just for one customer. Like most of today's early adopters, we too started by creating a virtual 3D factory using an easy-to-use software package, and this allowed us to experiment with different setups. But there are problems when you start harnessing the Internet of Things and deploying cyber-physical systems. You generate mountains of big data.
Fortunately, smart systems are now available which make sense of that big data, delivering the factory decision makers the information they need. A typical text message might read, "Motor drive 10 on conveyor belt B requires maintenance. Please press confirm to order the parts." Creating your UK factory of the future is going to require skills. People, engineers, technicians. But what skills are going to be needed? Where are these people going to come from? And who's going to train them? To answer that question, I travelled to Coventry to one of the high-value manufacturing catapult centres, the Manufacturing Technology Centre, where they've just opened the Lloyds Bank Advanced Manufacturing Training Centre.
There's no point generating the technologies unless you also generate the people who can use those technologies. The engineers and technicians that go through this training centre will have a grounding in all of the.
See, what they are saying is there is no sense in making technologies if you do not have the skills of the persons who can use these technologies.
Old technologies, but technologies. The engineers and technicians that go through this training centre will have a grounding in all of the old technologies, but then they will have all of the skills needed for the new technologies that we're developing.
So how do our engineering skills in the UK compare to those in the rest of the world?
I think the problem we have worldwide is there aren't enough engineers and there aren't enough people coming through with the right skills to really drive the industry forward. The unique thing about the centre is the access that we've got to all of the new technologies that we're developing as part of the Manufacturing Technology Centre itself. And the fact that we've got the people that are developing those processes that can teach the guys in the apprentice centre and really make sure that they've got the skills that they need for tomorrow's industry and not just the skills that were needed for yesterday's industry.
Creating the UK factory of the future is a big idea. No one company on their own could achieve this. It requires collaboration on a grand scale, a revolution in the way we think, communicate and collaborate.
We hope this short video has inspired you and given you an insight into how a revolution in new technologies, Industry 4.0, can enable you to accelerate your innovation, respond to customer needs and drive up productivity.
Themes can help you review your options, overcome challenges and provide the technology, equipment and engineering expertise to build your factory of the future.
Give us a call, we'd love to talk to you.
So, dear participants, I hope this, as you can see from this video, the major concern is there are two things. One is we are developing the technologies. Second is who will actually work on these technologies. Okay, we are talking about AI, we are talking about big data analysis, but we need the skills, we need the technicians, we need the engineers who will work on these skills. So if we are able to give them some know-how in our institutes while they are studying, give them small projects so that they can work on these skills, only then they will be able to be ready for the industry. So it is a big concern, future concern, that we are developing so many of the skills, but from where we will get the manpower for doing those skills. So going back to my presentation, let us move further. So we have already understood about these different technologies, what is the requirement and what are the skills which we require. Now I will talk a little bit about some other new technologies which are taking place. Let me share my presentation. Dear participants, when we talk about Industry 4.0, the next thing which is coming is the industrial metaverse, which we call as virtualization. In Industry 4.0, we were talking about cyber physical systems. Industrial metaverse means the entire virtualization. What is this industrial metaverse and what are the building blocks in this? Which type of skills we require? We require cognitive, then connected, virtual, human centered, and value added skills are required. What is this metaverse which we all are talking about? This is the next generation of internet based applications and social forms using various cutting edge technologies. These include virtual reality, augmented reality, 3D holographic avatars, video, and cloud computing. Basically, metaverse means in addition to the actual world, we have a virtual parallel world, which we call, as you must have heard this word, all of you, a digital twin of the real life. So, which is utilizing the physical, augmented, and virtual reality to provide a metaphor of real life for its avatars in a shared virtual environment through the internet. So, basically, metaverse is a virtual world which is interacting with in real time with their avatars. So I will show you certain examples how we are using this metaverse. So the industrial metaverse is defined as a connected whole system digital twin with functionalities to interact with the real system and in its environment, allowing decision makers to better understand the past and forecast the future. So there are different definitions by different industries. Siemens, Veda, all they have taken their own definitions. They have defined metaverse in their own words. But basic components of this metaverse are, okay, we have a real world. Please see here and try to understand this. This is the real world where the actual action is taking place. And this is a digital twin of that particular real world. From the real world, we are taking the data through connections, internet, and all. This data is given to the digital world. Some computation is done, some decisions are made. Then, these by collaboration, by conceiving the data, the final output is given to the real world. This is how the digital twin and real world are working in parallel with each other. So, what is a digital twin? An exact replica of the real world item, anything from a machine to a building block. Like we used to have these small models. So, that was also a digital twin only, but that model was stationary. Here, the digital twin means that it is behaving and it is working similar to the actual environment, the actual building or actual machine. To make it more clear, I will show you one small video also. But these are certain examples of digital twin. For example, Rolls-Royce company, they are using digital twin to test their planes. So engines, they are tested through their digital twin. Another example is they are constructing a crossrail in London. So a digital twin of that crossrail is first of all made in the lab. The real data is taken from here and then it is used to visualize, okay, in future these are the problems we are going to face with this. Another example of digital twin is in energy. If you see here, participants, this is the real ship. Let me enlarge this. This is the real ship. If you see here, this is going inside the actual sea. Similar to this ship, we have made a digital twin, digital structure of the similar ship in the lab. This can be in the lab. Now we are taking the real data, real time data from this ship, real ship, if you see here, and we are taking this data through cloud computing, and the real data is fed to the digital twin. This is a model or a twin of the actual ship. Now this ship is going in the sea and it is having certain real time parameters. For example, let us say it knows that this is the wind, this is the speed of the wind, this is the temperature of the water, this is the direction I am moving. So all this is the real time data. From there, this is the speed of the ship. So all this real time data will be collected through this cloud and the real time data will be given to the digital twin. Now this digital twin is similar to the real. It will take the data from here and it will see, okay, this is the temperature, this is the load of the ship, these many people are there. So if this ship keeps on going in this direction, it can face this difficulty. So it will warn, it will make some testing, it will make some decisions, and it will give warning to the ship, can give warning to the ship, "Okay, this is not the correct direction, you may take a different direction, wind is not fine." So this is how it can help in working of the real environment. So what is actually happening, how it is different from another model, it is taking the real time data, in real time it is collecting data from the actual ship which is moving. So this is the basic concept of digital twin. I hope you have understood. Wherever is the actual model, actual machine, the parameters from here are given to the digital twin. The digital twin will take certain decisions and then it will give its output to the actual ship. This is how they are using it in energy. A digital twin example, how they are utilizing it in the energy. Similar example is for electric cars and other cars, autonomous cars also. They are making, first of all, the digital twin. The actual conditions are fed to the digital twin car, and then the decisions are made according to that. Similarly, some developed countries like Singapore and other countries, we have heard that we are making here, they have said that Chandigarh will be also a smart city. They have taken this decision to make it a smart city. So they are using this digital twin technology in smart cities also. Let me show you an example. In Singapore, they have a lot and lot of data coming from each and every part of the city. So they have a virtual twin of Singapore city in their labs or in their control room. So they collect the real time data. For example, let us take one example for traffic only. They have the real time data from the traffic, they have cameras and all. So that real time data is going into their virtual Singapore model. In this digital twin model, they will see, okay, if we keep on going from here, if we the traffic is too much here, the congestion is too much here. So they have got the real time data, they can make certain decisions, input is given to this virtual model, they can make certain decisions, and then they can divert the traffic to certain other side. Okay, here there is a risk of congestion, so we can divert the traffic to from other side, it will lead to lesser traffic congestion. So this is how the digital twin is used in the smart cities. In some modern developed countries, they are using a digital twin model for the cities also. For other cases also, for example, for supply of water, supply of electricity, there also they can use the digital twin. So participants, hope you are understanding the concept, what we understand by this new latest technology of digital twins. So this is how you can make a this is how the digital twins are working. So participants, whenever we talk about certain advantages, there are always advantages and disadvantages of any revolution of any industry. So here industry 4.0, it also has certain advantages which we have seen during the presentation. If we have good productivity, good flexibility, lot of profitability, better customer experience, better safety can be there, customization can be there, optimization can be there, and this is one example. But there are always certain challenges also involved with any revolution. Certain challenges of industry 4.0 are like, we have economic problems are there, social problems are there, poor countries, they cannot afford so much of infrastructure. Socially also, people don't want to accept these latest technologies. When computers were introduced, people were reluctant to use computers. Technical problems are also there, from where we will get so much of technology. Then employment problems are there. If everything will be done by machines, where will our manpower will go? Organizational structure problems are there. Some political challenges are also there. So these are the different challenges which we can face by industry 4.0. So in the end, dear participants, I will like to show you again one small PPT. So skilled labor we have talked about. After this, I will show you a small PPT, video of the digital twin. So cybersecurity problem is there. We all know money frauds are taking place in this online. Like just Aman Chawla sir told me, "Ke ma'am, your camera might have been hacked, since I am not able to switch on my camera. Some other application is taking place." So cybersecurity is a big risk. If we are saying we are going to industry 4.0, everything will be available on internet, so that will be a problem. In 3D printing also, we are saying that there are a lot of drawings available on the internet, so there also there are certain problems, cybersecurity problems are there. skilled worker. This is the major problem. So much technology advancement we are talking about. From where the students will get the skills? Who will teach them these skills? How they will learn the skills? Then whenever we are talking about any change, there is objection from the IT department. Social issues are there, impact of industry 4 on society, lot of urbanization and industrialization. Capital cost will be there. From where we will get the money for building such a high infrastructure? Technical challenges are there. So dear participants, let me show you a small video of this digital twin. Then we will have few questions from you. We can interact, have a small interaction before we end. Let's start from the beginning. Okay. So you can see this digital twin of the ship. Similarly, windmills. Windmills, the digital twin is there in the lab. It is collecting the data. All these are interconnected. In manufacturing also they are using digital twin. Automotive. Construction. Utilities. Healthcare also. So participants, digital twin is the next thing now.
Madam, our participants are interested to have your PPTs. Can you please share it?
Definitely, sir. I will share with sir. I will share my PPT with sir. You can share with your students. No problem, sir.
Okay, thank you very much, madam.
Welcome, sir. So, dear participants, I think, okay, we can have five. We can now, let me cancel this. I am not able to switch on my camera, but I think we can interact for the last few minutes. So, in this PPT, starting with the project work, what type of projects you can get. We have talked about the technical skills. I have here talked about the technical skills since you are all from the technical fields, polytechnics, engineering colleges. So this is our moral duty to teach some latest skills to our students. For this, you can give small projects. If you have a 3D printer, you ask your students to make a small project in 3D printing. These days, many colleges, they are giving small projects with drones, assemble a drone, how to make a drone, how to fly a drone. So you can give some projects related to drone technology. Then in IoT, you can using during this COVID period, many students made a number of projects like they made certain bells, sensors, these thermometers, sensor based thermometers. All these things can be utilized. The latest technologies can be utilized for the project work of your students. Computer people can give them some programming, some art in related to artificial intelligence, cyber security, and all. So this is all from my side, dear participants. So if there are no questions, Gupta sir, I think I will take your leave.
Excuse me,
Yes,
madam.
yes, Urmikar sir.
Yes, yeah, madam. Can you please elaborate what is the fourth dimension in the 4D printing? What is the
What
fourth
is
dimension? What is the
4D
fourth
print?
dimension?
4D printing?
What is the fourth dimension in that?
Yes, sir. Okay. 3D printing, you all know length, breadth, and height, right? So
Yes.
I have made one object, some particular object. Let us say, have you seen this sponge? There is a material, I have it at my home. It is a smelling thing. It has very small droplet. When I put water in it, then it expands, right? So basically 4D printing means you already have 3 dimensions. Under certain conditions, like let us take an example of sponge. If I put water in it, it will expand. So under certain conditions, it changes its fourth thing. Either it can be shape, either it can be volume, or either it can be color. You must have seen certain things that when you apply pressure on it, it changes its color. So that is the fourth dimension. So what we do in 4D printing, we make a object, smart object using 3D printing. 3D प्रिंटिंग से आपने मटेरियल बना लिया, बट अगर उसका प्रेशर चेंज होता है या टेम्परेचर कोई एक्सटर्नल फैक्टर के अंडर, वो अपनी एक और चीज चेंज कर लेता है, जैसे वॉल्यूम, शेप या कलर, तो उसको हम 4D प्रिंटिंग कह देते हैं कि इसने फोर्थ डायमेंशन भी चेंज कर ली, but under certain pressure, under certain environmental condition. तो आई वॉज रीडिंग वन पेपर ऑन बायोमटीरियल्स, तो उसमें मैंने देखा कि एक उन्होंने ऐसी ड्रग बनाई है, टैबलेट बनाई है या कैप्सूल कह लो, तो वो बॉडी में अगर तो पीएच 7 है, लेटस से अगर तो बॉडी का पार्ट एसिडिक है, लेस देन 7 है, तो हमें थोड़ा अमाउंट मेडिसिन का चाहिए. अगर किसी पार्ट में, इंटेस्टाइन, स्टमक, किसी भी पार्ट में उसका पीएच वैल्यू ज्यादा है, तो मुझे थोड़ी डिफरेंट अमाउंट ऑफ मेडिसिन चाहिए. तो इन्होंने क्या किया, यूजिंग 3D प्रिंटिंग दे हैव मेड अ टैबलेट और अ कैप्सूल टाइप विच विल यू विल स्वॉलो. दैट कैप्सूल इज फिक्स्ड. 3D से बना लिया हमने 3 स्ट्रक्चर्स, बट जब वो ऐसे बॉडी पार्ट में जाएगा, लेट अस से इन अ स्टमक वेयर द पीएच वैल्यू इज लेस देन 7, तो उसकी एक ऐसी डायमेंशन चेंज होएगी कि इट विल गिव दैट अमाउंट ऑफ, ये वो इतना एक्सपैंड करेगा कि उतना लिमिटेड अमाउंट ऑफ मेडिसिन इट विल गिव. दैट मीन्स अब इसकी फोर्थ डायमेंशन चेंज हो रही है ना. सिमिलर अगर वो पीएच वैल्यू ज्यादा में जाएगा, तो उसकी सेटिंग ऐसी हुई है स्मार्ट मटेरियल की, 3D मटेरियल की, कि उसकी एक्सपेंशन कम होएगी, तो वो कम मेडिसिन करेगी, मींस वो कंप्रेस हो जाएगा. अब ये कंप्रेस और जो एक्सपैंड हो रहा है, ये इसकी फोर्थ डायमेंशन चेंज हो रही है. इसी तरह हम कई लाइट्स बना लेते हैं कि अगर टेम्परेचर कम है तो उसकी डिम लाइट हो जाएगी, अगर टेम्परेचर ज्यादा है तो वो लाइट ऑन ज्यादा हो जाएगी. तो उसकी फोर्थ डायमेंशन चेंज हो रही है अंडर सर्टेन एक्सटर्नल फैक्टर. दिस इज व्हाट वी अंडरस्टैंड बाय 4D प्रिंटिंग. मटेरियल 3D प्रिंटेड ही होएगा, अब उसकी फोर्थ डायमेंशन चेंज हो रही है. पहले 3 डायमेंशन थी, लेंथ, ब्रेड्थ और हाइट, लेकिन अब उसकी फोर्थ डायमेंशन चेंज हो रही है विद रिस्पेक्ट टू सम फैक्टर्स. कई बार टेम्परेचर में हो सकता है, कई जैसे आपने कई चीजें देखी हैं कि टेम्परेचर बढ़ जाता है, वो एक्सपैंड कर गई, तो वो एक्सपेंशन जो हुई है वो उसकी फोर्थ डायमेंशन चेंज हुई है. देन वी कैन कॉल दैट मटेरियल एज 4D मटेरियल.
Okay, thank you मैडम.
So this is a basic concept. अब ये भी हो सकता है somebody, पहले तो ये सोचना बड़ा मुश्किल था भाई 4D, अब you never know, there might be something called as 5D also, कुछ और भी चेंज कर दे, फिफ्थ डायमेंशन भी चेंज कर दे कोई, मे बी द इन फ्यूचर. बट इट इज अ वंडरफुल एप्लीकेशन दे आर यूजिंग, कि मेडिसिन को ही 4D बना दिया इन्होंने कि फॉर कैंसर एंड अदर एलिमेंट्स करने के लिए. तो वो मेडिसिन को ही ऐसा बना दिया कि उसकी डिफरेंट एक्सपेंशन होगी और डिफरेंट अमाउंट ऑफ मेडिसिन विल बी देयर. थैंक यू एवरीवन. आई विल शेयर माय पीपीटी विद सर. थैंक यू एवरीवन.